Alright, so you're here because you want to see a proof to the Pythagorean theorem. And so that's what it's in the title. And so that's what I'll do. I'll show you a proof to why the Pythagorean theorem works. Because most of us, or I mean, I won't say most of us, but a lot of us don't actually know why the Pythagorean theorem works. Just plug in all the values. But there's a relatively simple to understand proof here that I'll try and explain. So we have this triangle and we're trying to prove this. So what we want to do is we want to start off by simply making like a really big square. By really big, I mean just this size. We have this, 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 this. There we go. And so now that we have the square, I'm going to draw the right angles. And then I'm going to draw the sides. So we have A and B. And in this case, I'm going to portray B as the bigger side. But it doesn't actually matter for a proof. And so you might see a little square in the middle, just right here. And so that square in the middle, well, let's first prove it's a square. And for that, we say, okay, we have side, angle, side. It's a congruence theorem for triangles. Since all the triangles here are the same side, angle, and side, we can say that all these are the same. We have side, angle, side, they're all the same. This means that this inside part is a square because all four sides are the same. Now, we know that in our triangle here, this is the C side, right? So this being C, so the inside area must be C squared. Because C times C, that's how it works. We square one of the sides to find the area. And since the inside is now C squared, we're going to do one final thing here. And this final thing is going to be our proof. Firstly, what we're trying to do is let's try and find the area of the entire square. So if you want to just think about it in A and B, just only with A and B, how would you find the area of the entire square? I mean, well, I hoped you paused and think about it because, well, it is good practice. The way you do it, you just have this side being A, this side being B. So you just have A plus B for this side, and A plus B for this side, A plus B for this side, and A plus B for this side. So all the sides are just A plus B. So that's how you'd write it. You'd say A plus B, and then to find the area of the entire square, you'd square one of the sides. So A plus B the whole squared. This would be the area of the entire thing. Now what we're going to do is we're going to subtract the area of these triangles. Just remove these triangles areas. That way, if we remove the triangle areas as well, we get C squared. And then we find out what will be equal to C squared. So let's subtract the area of the triangles. So if you want, you can think about this as well. How would you do that? Remember, the side lengths of each triangle is A and B. And so, alright, the way you would do this, you have four triangles, obviously, and they're all the same. We just proved that. So since we have four triangles, 4 times, and the area for a triangle, remember, it's half one side times the height. And in this case, a 90-degree triangle, right? So the height is just B. In this case, let's just say, so we can just say half AB. And remember, this is equal to C squared. And so this is all the geometry. That's pretty much what it is. We put the area of the entire square, remove the area of the triangles. Now the only part left is the simplification. So let's just simplify this. That's all you need to do. This is already correct. You can plug in your A and B values and it will give you the correct answer. But let's simplify this just to show. Now 4 times half AB, that can just be rewritten as 2AB. And A squared plus B, A plus B the whole squared. This can be rewritten as A squared plus B squared plus 2AB. And then this whole thing is equal to C squared. Remember, we just simplified it. We didn't really do anything else. And if you look closely, we have the plus 2AB and the minus 2AB. So these two should cancel out, right? And so that's how we would write it. We'd say A squared plus B squared, because those are the only two things left. We cancel these out. And that is equal to C squared. And that's it. We proved it. Remember, this is also a completely correct variation. However, we simplified it down into this. And that simplified form is the form that we like working with. And it's the one that we've seen. I hope you enjoyed this video, as this is not the only way to prove the Pythagorean theorem, but it's a really common way to do it. So it's also pretty simple to understand, so that's why I chose it. I'll see you in the next video.